Alright, welcome back. In this video we're going to move forward and talk about some quadratics and some factoring. And hopefully the quadratics are something you studied heavily in Algebra 1 and Algebra 2. In this one we're going to be distributing, factoring, and solving equations. We will not be completing the square. That's something that you may have done last year in Algebra 2. I don't think we'll need to do that in this class, but if the need arises, we will tackle that when it comes up. So just to remind you about what a quadratic function is, it's a degree 2 polynomial that can be written as f of x equals ax squared plus bx plus c. Typically we call that standard form. I might write that in. So we talked about this a little bit last time, the graph of y equals x squared minus 4, the same example to start with. And we saw that it was a parabola that had a y-intercept of -4. And so I think the thing I was supposed to tell you about this was that the graph of a quadratic function is always going to be a parabola. And then let me just show you a table of values. I'm going to give a couple of more values than I did last time, but I'll just fill in the table for you. And this is kind of a preview of where we're going with this stuff, because this will be a concept I need to tell you about for AP Precalculus. But something you did know about in Algebra 1 in Texas for the STAR exam, and we also talked about in Algebra 2, was the idea of like the constant second difference in the table. So provided that we have evenly spaced x's in the table, which we do, -1, 0, 1, 2, 3, each time bumps up by 1. If we look at the first difference, which basically tells us about the rate of change of the function, it's not going to be constant. Okay, so to go from -3 to -4, I decreased by 1, but then I went up by 1, I went up by 3, and then I went up by 5. And if I look closely at the second order differences, or the rate of change of the rate of change, I should see a constant. And so here, to go from -1 to +1, I increased by 2. I'm seeing the same thing here and the same thing there. And so what I would say about a table for a quadratic function, provided that x's are evenly spaced, is that it has a constant second difference. Sure, yeah, that barely fit in. Okay, but that's, we will talk more about that constant second difference property in the next unit when we go in and talk about rates of change. So in the last unit, in the last lesson, we were always able to directly solve for x by just like doing the same thing to both sides of the equation, right? With x squared minus 4 equals 0, we solved that one. We added 4 to both sides and then took the square root of both sides, and we got plus or minus 2. I'll just copy in the work for the next one. We saw a couple of those on the homework, I think we did it on the quiz too, but we were able to directly solve because it was like x plus 1 squared. Really what had happened was somebody had already completed the square for us, but that's not something we'll have to worry about doing on our own. Okay, we're going to need to be able to solve equations like x squared plus 6x plus 5 equals 0 though, and the thing about this one that we won't be able to just like do the same thing to both sides and solve is because of the more than one power of x moving around at the same time. Okay, what we're going to need to do with this is probably factor, and that doesn't work quadratic formula, but today everything will be factorable. And so I'll talk about factoring, but first, before you really get to factoring, you have to think about distribution. Having taught Algebra 2 last year, I saw in my class that the distributive property was one thing I could really depend on students to do properly. Okay, we had issues with factoring sometimes with solving equations, but with distribution, we were actually very good. Okay, so I'm just going to remind you of some things that I suspect you already know and are pretty fluent in, like this 2x multiplied by x plus 5. Remember, if I'm distributing over the addition x plus 5, which is what I really mean if I'm taking 2x and I'm multiplying it by the whole thing, I need to multiply the 2x by the x and the 2x by the 5. Okay, so this is going to be equal to 2x times x plus 2x times 5. And this line I just wrote in red, you probably don't do that very often. I hardly ever saw people doing that. I just saw people going straight to the answer because they knew how to multiply 2x by x. Okay, that's 2 total powers of x, so I have a 2 and x to the 2 power. And then with 2x times 5, I'd multiply the 2 and the 5, keep the x the same because they're not the same type of thing, and I'd have 10 times x. Okay. Most people, almost every time in my Algebra 2 class, were able to get from 2x times x plus 5 to 2x squared plus 10x. So I'm hoping that you still have that skill. And then if I had binomial by binomial, it kind of varies in our district, how you were instructed in Algebra 1 to do this. If you want to do a box for this, that's exactly what you should do. If you want to draw the rainbows and do FOIL, that you can do that too. Me personally, I learned FOIL, so that's kind of how I think about it. I'm going to do the first two. X times x is x squared. The outside is 3x. The inside is negative 7x, and the last two is negative 7 times 3 is negative 21. Then we would collect like terms and say x squared plus 3x minus 7x would be a total of negative 4x and minus 21. Okay, now why don't you try the next two on your own? Or actually, there's four more, right? Yeah. Looking around, at people's papers in my class while they were doing this on their own, I saw that y'all are still good at this. But what I would like you to do if you're watching this at home and kind of just working through this, having not done it yet, is try to do all four of these and then see if you can come up with a trick for multiplying x plus a times x plus b, because that's going to get us towards our trick for factoring. That's the idea. So do these distributions. I would say with the bottom two, be very careful. It's not going to be x squared minus 16 or x squared plus 16 or x squared plus 49. We need to actually write out x minus 4 times x minus 4 and do FOIL or the box method or whatever we do. So try these with the video pause, because the answers are going to come up in 4 or 5 seconds. All right, there you go. So x plus 3, x plus 1, I ended up with x squared plus 4x plus 3. Okay, the other one, x squared minus 2x minus 15. And then for the squared binomials, you can see what I got there. Okay, so if you figured out the trick, good for you. If not, I'm just going to show you what I'm talking about. So I'm over here, I'm saying, when I multiplied x plus 3 times x plus 1, the number in the middle was the sum of those two, the 3 and the 1. And the last number was the product of them. Same thing for the second example. Negative 5 and 3, I add those together and I get negative 2. I multiply them, I get negative 15. With x minus 4 squared, if you look at it as x minus 4 times x minus 4, you add those together and get negative 8. You multiply them, you get positive 16. It's the same story down in the bottom right. So what's going to happen is I'm going to get x squared. The middle number, which gives me the number of x's, is going to be the sum of a and b. And then the last number is going to be the product of a and b. And really what we need to do is we need to internalize this so we can do it in reverse for the factoring. So let's kind of like move forward and see how that's gonna go. And I said we were going to go forward, but I actually went backward in the notes to this thing where it says x squared plus 6x plus 5 is equal to 0. Okay, what we're trying to do here is we're going to factor this thing so that we can solve it, and I'll remind you why that would be useful in the first place, kind of down below. But what I want to do is I want to take this and I want to write it as the product of two binomials. Kind of undo that distribution that we were doing just a second ago. And so you may remember that when we were factoring, we're looking for two numbers that multiply to 5. Whoops, couldn't see that. Try that again from the other angle. Multiply to 5 while adding to 6. If you think about it, two numbers that multiply to 5, well, it's got to be 5 and 1 if they're going to be whole numbers. And adding to 6, yeah, they do. Okay, so I would say positive 5 and positive 1. That's equivalent to x squared plus 6x plus 5, because if I did the FOIL, if I did the distribution, that's what I would get. Okay. And so that's how we're going to factor. What we're going to do is eventually employ the zero product property, but I think I'm going to leave this here for now and just kind of go down to the thing where it says factoring. All right, so just to remind you about what factoring is, I've said it, it's the process of undoing distribution. And the benefit of it is that it can allow us to solve equations that otherwise we wouldn't have solutions to, specifically by using the zero product property. And this is something that you kind of had internalized inside of you since probably about elementary school, when you started thinking about multiplying numbers. So if we have two numbers, and maybe I'll call them x times y. If we've got x times y equals 0, we know that either x is 0 or y is equal to 0, right? Because we can't take two non-zero numbers and multiply them and get 0 back. It's just not going to be possible. So this means necessarily that either x is equal to 0 or y is equal to 0. So if I went back to that example of x squared plus 6x plus 5 equals 0, and I wasn't able to solve it directly, by doing the same thing to both sides of the equation, if I could write it as the product of two binomials, maybe I could solve the binomials. That's the principle here. So let's go in and do this a little bit. And, as we're starting, I'm going to just tell you that in AP Precalculus, they tell us exactly which types of factoring we have to be able to do. And it's not all the types of factoring that you learned about in Algebra 2. There's not going to be any sum or difference of cubes. There's not going to be group and factor with 4 terms. It's really going to be greatest common factor and what we would think of as like Algebra 1 type factoring, where, like I was saying, we're looking for 2 numbers that multiply to this and add to that. Okay, so first example would be find the x-intercepts on the graph of y equals 3x squared plus 12x. And we talked about x-intercepts last time. Those are places where y is equal to 0. So I'm going to start off by decoding that. Y equals 0. I've got a formula for y. That's 3x squared plus 12x equals 0. Okay. And what I'll tell you, like you might say, okay, maybe just divide both sides by x. And you can, but you'll lose a solution. Okay, what we want to do is we want to factor this thing so we don't lose track of any of our solutions. And what we should always do is start by searching for a greatest common factor. So you think about 3x squared, that's like 3 times x, and then 12 times x. And you think about what do those have in common to them. Well, 12 is divisible by 3, and both terms have at least one x in them, so I'm going to factor out a 3 and an x. What I'll be left with is really each of these terms divided by 3x. But I think to myself, what do I multiply 3x by to get 3x squared? And really that's kind of what division is. But if I think about, okay, 3x times x would be 3x squared. That's what I'm left with here. And then over here, if I'm factoring out the greatest common factor of 3x from 12x, I say to myself, what do I multiply 3x by to get 12x? That would be a positive 4. Now I've got, the product of two things equaling 0. So I can apply the zero product property and say that it's either going to be the case that the red thing is equal to 0 or the blue thing is equal to 0. And that's where we can get more than one solution to an equation. So I can either have 3x is equal to 0, and I stop to myself, or I stop and think to myself, what number do I multiply by 3 to get 0? Okay, only 0. That would be x is equal to 0. Or I could look at maybe x plus 4 is equal to 0, and I can solve that. You could either solve it with your eyes, or you could solve it by subtracting 4 from both sides. And either way, you're going to see x is equal to negative 4. Okay, so my solutions are going to be 0 and negative 4. Okay, those are the x-intercepts on the graph of y equals 3x squared plus 12x. This is one you can try on your own. When they ask you for the zeros of a function, that's just where the function's equal to 0, it's exactly like an x-intercept. Also, solutions and roots are two other vocabulary words that are talking about the exact same thing. So I know it's a lot of terminology, all talking about the same thing, but people developed these mathematics all across the world using their own languages, using their own terminologies and stuff, and so sometimes vestiges of that still show up, and since we got like 4 different words to represent the zeros of a polynomial. Okay, so what I mean here is f of x is equal to 0, but you should try this on your own because it's the greatest common factor. You do the exact same thing. I'd work this with the video pause because I'm going to bring in the solutions in just a couple seconds. Okay, there you go. So I set the thing equal to 0, negative 8x squared plus 12x equals 0, and then I factored that. Now, if you wanted to factor out the negative because you don't like the negative being in the front, that's fine. I mean, up to you. But I just factored out the 4 and the x because I saw that was coming. I was left with a negative 2x plus 3, and I was able to get 2 solutions from there using the zero product property. And after checking for a greatest common factor and possibly factoring it out, we'll look to factor any quadratic into the product of 2 binomials using the trick we were just talking about earlier, where we were looking for 2 numbers that multiply to this and added to that. So I think last year in Algebra 2 I used m and n, but that was, I don't know, maybe I'll use u and w this year, because those are letters we don't use a whole lot in algebra or pre-cal or whatever. So write the polynomial x squared minus 4x plus 3 in factored form. Okay, so what we're doing is we're looking for 2 numbers that multiply to the last number, to that positive 3, while adding to negative 4. Okay, so the only whole numbers I can think of that multiply to 3 are going to be 3 and 1. And if they need to add to negative 4, maybe I could use negative 3 and negative 1. So I'm going to go over here and I'm going to say, all right, this thing can factor up into x minus 3 times x minus 1. But if you're ever unsure of like the way that you factored a polynomial, you should check. And I don't necessarily mean like check by scribbling out the foiling or the box method off to the side. Just kind of mentally check. Think about what would happen if I did the distribution. I have x squared minus 3x minus another x, that's negative 4x. And then negative 3 times negative 1 makes that positive 3. So I feel good about that factoring. I wrote it in factored form. Now this next one, I think this is going to have both in it, right? It's going to have it's going to have a greatest common factor, and then we will continue factoring after that. So I'm going to take out the negative 2, okay? Because I really don't want the leading coefficient of the polynomial to be negative. I'm no good at factoring if the leading coefficient is negative. If it's just negative 1, I'm still factoring out the negative and just holding that off to the side. So I've got negative 2 multiplied by x squared plus 5x plus 6. Oh yeah, and this is a tricky polynomial because there's 6 can be 6 and 1, which could, if it was positive 6, negative 1, that would be 5. But it can also be 3 and 2, which adds to 5. So you gotta always be careful with the 5 and 6. If I'm looking for two numbers that multiply to 6 and add to 5, that's going to be positive 3 and positive 2. So what I'll have is, x plus 3 times x plus 2, standing in where that quadratic had been. But I still have that negative 2 on the outside, and that's going to be factored form for that polynomial. Now, occasionally, we might run into a polynomial where the leading coefficient is not 1, and it's not a greatest common factor. I don't think it should be very common in AP Precalculus because I've taught AP Calculus for a long time and it is exceedingly rare to run into one of these. And the factoring rules seem very similar from AP Precal to AP Calculus, like you might expect. So I don't think we'll have to do this very often, but it's good algebra. It's something we focused on in Algebra 1 and Algebra 2, so I'm going to bring it back and make sure we're fluent in case we need it. So in this situation, if I can't factor out the 2 from all three terms, what I'm going to do is I'm going to take the 2 and the negative 9 and I'm going to multiply those. And that's what I'm looking for u and w to multiply to. So u times w equals 2 times negative 9, which is negative 18. Okay. And then u plus w still needs to add to negative 3. Let's see if I can get that all on the screen. U plus w equals negative 3. Okay, so I'm thinking like somehow 6 and 3, because 6 times 3 is 18 and 6 minus 3 is 3. So if I want this to add to be negative, I'm going to need negative 6 and positive 3. But the thing is here, what we're going to do is after we identify these numbers, we're going to express the middle term in terms of those two numbers. Okay, so that we definitely made sure to make it so that they added up to that, so we will be able to split along those two numbers. So what I'll have is 2x squared minus 6x plus 3x minus 9. What we'll do is we'll kind of block these off and work them two at a time. So what I'm saying is we've got this plus that. Okay? And so with the first expression, I look for a greatest common factor. And I've got 2x multiplied by x minus 3. And then with the second one, I've got the 3x and the minus 9. I can factor out a 3 from that. And I'm left with x minus 3 again, if I've done this right. And it was factorable in the first place. But the thing is, today I'm only giving you stuff that's factorable. In the long run, you run into this, you want to find the zeros, you might just use the quadratic formula, and that would be totally understandable. Okay, after this, I'm going to factor out the x minus 3. Because if you look at it over this addition right here, each of the terms has an x minus 3. So I can factor out that x minus 3. And I'll be left with the 2x from the first expression and the 3 from the second expression. That's how we're going to factor if the leading coefficient is not 1 and is also not a greatest common factor. But I'm telling you, I really don't think this is going to happen all that often. All right, and if you're interested in why this technique works, I would have you just look at the kind of handwriting that I copied in along the right side of the page in the notes book. If you look at this and kind of like toy with it yourself, you should be able to see why it works. But if you are interested and you're not understanding that stuff on the right, you can come and talk to me about it, and I'd be happy to work with you on that and try to convince you of why that technique works, and it's probably going to be the way to go if you need to factor that thing. But again, I really don't think you should have to factor these all that much. All right, so let's do a little bit of practice. Okay, let's try these four. You should try these on your own. Solve these equations by factoring. I think the thing I need to remind you about is that for these two equations here and there, we're going to need to start by setting these equal to 0 because it's a 0 product property, not an 18 product property. Okay, so we start by subtracting 18 or subtracting 11x from both sides, set the thing equal to 0, solve with the 0 product property. Okay, so you should work this with video pause because I'm going to just bring in the answers in 2 or 3 seconds. All right, there you go. So, this was 4 factoring problems, really just kind of getting you started on the type of problems you're going to work on the homework. The bottom 2, like I said, I really don't think we're going to need to do that all that often. Maybe at most occasionally in this class, but the upper 2 I think are going to be the type of equations we will need to solve on a regular basis. What I really wanted to point out to you about especially the top left equation, is that, okay, really we've got 3 things right here multiplying together to equal 0. And a very common error is taking that 6 and making that one of the solutions. But that's not going to contribute a solution, because I just want to remind you that if these 3 things multiply together to equal 0, one of them has to be equal to 0. So it's either going to be the case that x plus 1 equals 0, which gives us a solution, or x minus 3 equals 0, that's another solution. The third option is that 6 equals 0, but we know it doesn't. Okay, so that doesn't contribute us a solution, and that's why that 6 isn't really impacting the solutions that we have. We factored it out first, and it's there. It's making the graph narrower or something, or taller, I guess is probably a better characterization. But it's not actually impacting the number of solutions. So that's going to leave that there. All right, another example, and this one I think is related to maybe like a multiple choice question on the test or something. We might have to solve an equation by doing a little bit of distribution first and then factoring, right? Because again, there's no 12 product property. So what we're gonna have to do with this one on the left is we're gonna go over and distribute x minus 3 times x plus 1, but we'll use that shiny new trick we developed. We know the middle term is gonna be the sum of the 2 numbers in the binomial, so I'll have x squared. Negative 3 plus 1 is negative 2x, and negative 3 times negative 1 is negative 3. And then if I'm gonna try to solve this quadratic that has more than 1 power of x in it at the same time, I'm going to have to set it to 0, so I'll subtract 12 from both sides. And then I will factor. Okay? I'll factor this thing up. I'll look for 2 numbers that multiply to negative 15. It's got to be 5 and 3 somehow, and add to negative 2. Yeah, so it's going to be negative 5, positive 3, because I got to add to negative 2. So x minus 5. X plus 3 equals 0, and that's going to give me x equals 5 or x equals negative 3, right? If x minus 5 equals 0, that's only going to happen when x was 5, and if x plus 3 is equal to 0, I'm visualizing what number do I plug in there to make that thing 0, and that's going to be negative 3. Okay, now you try the one on the right on your own. Okay, try it with video pause, because I'm not going to waste a whole bunch of time showing you the steps. I'm just going to show you the answer, and if you need more support with that particular one, that's something I would ask you to come talk to me about, leave a comment on the bottom, whatever you're going to do. Okay, but just follow up with me on it if you have trouble. So pause the video, work it. I'm going to bring it up in 3 or 4 seconds. All right, there you go. So I squared the x minus 4. Okay, you have to be very careful. Remember that it's x minus 4 times x minus 4, but it seems like y'all are doing pretty all right on that. That's x squared minus 8x plus 16. I add another x like it told me to, and that's equal to 4. So I combine some like terms, negative 8x plus x, it's a negative 7x. I set it equal to 0, factor, and solve each factor. The last thing I've got for you for this video is a sample free response question. And so I'm telling you now, like, the tests in this class are always going to be part multiple choice and part free response. And in this class, the free response is very prescripted. Like, they're telling you what's going to be on the free response and on the AP Pre-Cal exam. Like, okay, and we're just going to work within those structures and get good at that so that we can, hopefully obtain the credit. Okay, so in keeping with that, I'm going to show you a lot of the stuff that I'm going to ask you on the free response sections of the chapter tests in this class. So for f of x equals 2 times x plus 3 times x plus 4, I could start by asking you to write this thing in standard form, find the values of a, b, and c. That would just be a distribution question. So 2 times I might do x plus 3 times x plus 4. And out of respect for the people that like to do the box method, I might go over here and make a box with x plus 3 and x and plus 4. I'm not against the box. I just only use it if I have like a trinomial or higher, if I have just more than a binomial by a binomial. Okay, but there's nothing wrong with using the box. It's the same thing. It's making sure we're hitting all of the things by each other. Okay, so I've got x squared plus 7x plus 12. I do have 2 of those, so 2 times x squared plus 7x plus 12. Okay, you could have also used the trick we developed if you wanted. So I'm going to say that's 2 times x squared, 2 times 7x, and 2 times 12. Okay. And so, if they're looking for the values of a, b, and c, I'd say a was 2, b was 14, and c was 24. You do not have to box your answer in this class. I'm just doing it kind of to draw your attention to that as the solution. So find the coordinates of all x-intercepts on the graph of y equals f of x. Okay, fortunately for us, this thing's already factored, so our job is not too hard. So I'm going to say f of x equals 0 because that's the hallmark of an x-intercept. Right, just going to, whoops, definitely want a black pen, not a black highlighter. F of x equals 0, that's where 2 times x plus 3 times x plus 4 is equal to 0. So if these three things are multiplying together to equal to 0, either 2 is equal to 0, which we know is not, or x plus 3 is equal to 0, so that would be where x was equal to negative 3. If it's an x-intercept, y is equal to 0. Or x plus 4 is equal to 0, which would give me negative 4 and 0. Those will be my x-intercepts. Coordinates of all y-intercepts on the graph of f of x. Okay, if it's a function, you can only have one y-intercept. If you think about it, if it had more than one y-intercept, wouldn't pass the vertical line test, right? Because y-axis is a vertical line. So I'm going to say, well, if f of x, I'm going to copy the function because it's out of sight now, x plus 3 times x plus 4. Okay, the y-intercept is the value of f of 0. So I'll plug in 0 wherever I see x in the formula. So I'll have 2 times 0 plus 3 times 0 plus 4. And that's equal to 2 times 3 times 4. So that's 12 times 2 is 24. Oh, but it said to find the coordinates. So I'm going to say, all right, that's where x is 0 and y is 24. Okay. Then we'll wrap up with finding any value of x that satisfies the equation f of x equals 12. Well, we've got our formula for f of x, x plus 3 and x plus 4, and that's equal to 12. So much like that problem we just did a couple of minutes ago, we're going to need to distribute it out, set it to 0, refactor, and then solve. So I think I'd like for you to try this one on your own, challenge yourself if you think this one's going to be a challenge, or if you think you've got it. If you can do this problem, I think you've achieved what I need you to achieve in this lesson. So try it with the video paused for the last time. I'm going to bring in the answers in just a couple of seconds, and that'll be all. All right, there we go. So like I said, I distributed. But actually, I used the work that I did up in part A to save myself the effort. I just kind of copied in the result, 2x squared plus 14x plus 24, set it equal to 12. Subtracted the 12 from both sides to get it equal to 0 so I could factor and apply the zero product property. I did factor. I saw it. This ray of light is really throwing me off. Saw there's a greatest common factor of 2, kept factoring, got x equals negative 6 and x equals negative 1. Okay. So that's going to be it. So today we made sure we were solid with our prerequisite skills in quadratic functions, specifically algebraic manipulation. That's the distributing. Polynomial multiplication, I guess that was actually the distributing. Maybe algebraic manipulation is, I don't know, doing the same thing to both sides of an equation. Factoring, definitely that, and solving equations. We did all those things. I'm really glad we're doing these prerequisite skills at the beginning of the course. We had a little bit of extra time when we budgeted out for the year. And your effort in these, or your patience, if you feel like you're already good on this, is greatly appreciated. Like I said before, I'm really glad you signed up for the AP Pre-Calc class. I'm really excited to work with you. And so I hope to see you back for the next lesson in just a couple of days. Thanks for watching.